So for the first part of today's lecture, we'll be working on some word problems. And these word problems, they were obtained from the 016 module. I just replaced some of the figures and values from the module. So you can also work on the same problems from the module, and you can just follow the solutions that I'm going to present. Okay, so first problem, solve. The difference between 3 times a number and 7 is 32. So find the number. Okay, so the difference between 3 times a number and 7 is 32. Find the number. So remember, in solving word problems, our first step is to analyze the problem. Okay, and also identify what is being asked. So in here we have the situation, difference between 3 times some certain number and 7 is 32, and we are asked to find that number. So once we have identified what is being asked, we now start setting a variable for that quantity. So for instance, here we let x be the number, be the number. Okay, so we let x be the number. Okay, then we follow the description here. Okay, then according to the description, then the difference between 3 times a number, so the difference between 3x, okay, 3x and 7, okay, and 7, this is equal to 32. So is 32. Okay, so this description here, the first sentence in this problem, gives us the working equation. So this is the mathematical model that we are going to use. And then what's the next step? Once we have the model, we just compute for the variable x. Okay, we just compute for the variable x. So what do we do? So we can add 7 on both sides of the equation. Okay, but what we're going to do, instead of adding 7 for both sides of the equation, we skip that step. What we're going to do is to do the transposition, meaning if we move this 7 from the left hand side of the equation and move it to the right hand side of the equation, we put plus. Okay, so we have 3x, this is equal to 32 plus 7. Okay, so if you move this minus 7 from left hand side to right hand side, it becomes plus. Okay, so we skipped some step here, and it's fine, meaning we actually skipped the fact that we added 7 on both sides of the equation. Okay, and then here we have 32 plus 7, and we know that it is equal to 39. So now we have 3x equals 39. We can compute for x. So here what we're going to do is to divide both sides of the equation by 3. Okay, but what we're going to do now, so we will skip that part, or maybe let us write that part. So you have 3x divided by 3. This is equal to 39 over 3. So we divide both sides of the equation by 3. And 39 over 3, this is equal to 13. Okay? But in here we have 3x over 3. So the 3 here will cancel each other. Therefore, we have x equals 13. Okay? Okay? So in here, we are only finding the number, and our x is the number. So just for completion, let us just write the following sentence here or phrase here. That is the desired number is 13. Okay? The desired, so I think I will need a lot of space. Let me write in here. So the desired number is 13. Okay? So question on the first problem. Question on the first problem. No question? Great. So let us go to our next problem here. So similar problem. So here we have the sum of twice a number and 19 is 51. Find the number. Okay? So the sum of twice a number and 19 is 51. Find the number. So here we are asked to find the number, okay, satisfying this condition here. So we assign a variable to that quantity. So let x be the number. Let x be the number. Then we look at this. Then the sum of twice a number and 19. So meaning we add 2 times that number plus 19, okay, plus 19. So this is the sum of twice the number and 19. Okay, this is according to the situation, this must be equal to 51. Okay, so this is our working equation, and now all we need to do is to solve for the value of x. So very similar to the situation from the last problem. Okay, all we need to do is to solve for x, and again we can subtract 19 on both sides of the equation, and that will cancel the 19 here, or it's equivalent to transposing this 19 to the other side of the equation. So we have 2x equals 51 minus 19. Okay, following. And 51 minus 19, this is equal to 32. Okay? And this means we continue with the solution. So again, we can divide both sides of the equation by 2. So I will skip that part for the left-hand side. We'll just have x on the left-hand side, while on the right-hand side, we have 32 over 2. And 32 over 2, this is equal to 16. Okay? And then we conclude with the following. Therefore, the desired number, so the desired number is 16. Desired number is 16. Okay? question on this problem? Okay. So next problem here. Now, a wallpaper hanger charges a fee of $21 plus $12 per roll of wallpaper. How many rolls were used if the total charge for the hanging wallpaper or for hanging wallpaper is 105? Okay? So, a wallpaper hanger charges a fee of $21 plus 12 per roll of wallpaper. How many rolls were used if the total charge for hanging wallpaper is 105? So in here, according to our question, we are asked to find the number of rolls of paper or wallpaper. So we assign that we assign a variable to that quantity. Okay, so let x be the number of rolls, number of rolls used. Okay, then the total charge. Okay, then the total charge, or we let say t, let t be the total charge, total amount charge, total amount charge for the job. Let us say job. So total amount charged for the job. So this is what we want. Then, so what we're going to do is to give a relationship between t and x. Since t is the total amount charged for the job, and if x is the number of rolls used, then t, this is equal to what? Flat rate of $21. So we have t equals $21 plus, and then $12 per roll of wallpaper. So plus, here we have $12 times x. Correct? So x here represents the number of rolls used. And we are charging $12 per roll of paper. That's on top of the flat rate $21. So that's why we have it here. Okay? And then let me just remove the dollar sign for the moment. So we have 21 plus 12x. Okay? Now according to the problem, the total charge was 105. Now, since total charge is 105, since total charge, total amount charge, let me write it that way. So total amount charged is 105. We have the following working equation. So 21 plus 12x, this is equal to t, but our t now, it's 105. So from here, we just solve for the value of x. Correct? So from this equation here, we have what? So we transpose this 21 to the other side of the equation, which means that we will subtract it. So we have 12x equals 105 minus 21. And if you calculate this, 105 minus 21, that's equal to 84. Okay? And we continue with solving the value of x. We now have here 12x equals 84. So we will have x. This is equal to 84 divided by 12. Okay? And 84 divided by 12, this is equal to 7. Okay? So x equals 7, and x is the number of rolls of wallpaper used. So we just write the conclusion. Therefore, 7 rolls of wallpaper were used. Okay? Question. Now, look at how we solved the problem. Also, just try to observe how we are doing the solution. So at the beginning, we are assigning variables, okay, to the quantities that are given, or the quantities that we want to find, okay? And then after that, we write the working equation or the model, okay? And then after writing the model, we use the data given in the problem in order to solve for the value of x, or the value of the variable or the quantity. Okay? And then we end by conclusion. Okay? So therefore, 7 rolls of wallpaper were used. Okay? This is the most proper way of solving word problems. Okay, and I want to emphasize this because some students will start on the working equation. Okay, suppose you don't have this part here. Okay, say in an exam or a quiz or etc. Suppose you don't put this first two sentences here, and you started with t equals 21 plus 12x. Okay, without giving the description of your variables t and x, t equals 21 plus 12x is just an equation and does not give any interpretation. In fact, it has infinitely many interpretations. Okay? And some students, after starting with this equation, they work, and then x equals 7. And then they will just box x equals 7. So my question is, what does this x equals 7 represent? Okay? So from a given equation going to the solution of that equation, it doesn't mean anything in the problem. It's just one equation with solution x equals 7, etc. So I was asked by some students, do we really need to put this, or do you really need to put this part here and also the conclusion? Okay. Yes, you have to put that. You have to put that. X number of rolls used. And then the conclusion, therefore, 7 rolls of wallpaper were used. Okay? So these two parts here, the introduction, the presentation of the variable, okay? The presentation of the variable and the conclusion are as important as this middle part here. Because this middle part, it's your mathematics, but the first two here, okay, the first sentence, the presentation of your variable or the introduction of variable means a lot, okay, and it says a lot of things, okay, and the conclusion also gives you the answer to what is being asked. So do not start with, if you are solving word problems, do not just start with a working equation. Okay? Now, so there is a question. What if we only represented x and put the total total in the working equation immediately? That's totally fine. You don't have to put this t equals blah blah. Okay? So you can just put let x be the number of rows used, then 21 plus 12x equals 105. Okay? It's totally fine. Now, this part here, t equals 21 plus 12x, this part here is somehow important in a sense that what if there are several questions? What if there are several questions? So how many rolls were used if the total charge for hanging wallpaper is 105? Okay, what about the number of rolls used if the total charge for hanging wallpaper is another price and another price? Okay, so that several numbers, okay, that several data, okay, or input can be used to replace the t. Okay, so meaning what we are actually getting here, okay, is a formula relating the total amount charged and the number of rolls used. Okay, and we will be talking about what formula is later in the course. In fact, the second part of today's lecture. Okay, so yes, to answer your question, you can start with this. You have the variable x, okay, representing the number of rolls used, and then according to this, so since total amount charge is 105 and blah blah, okay, meaning the charge, the total amount is calculated by 21 plus 12 times roll of paper, okay, then you will have this working equation, 21 plus 12x equals 105. It's totally fine. It's the same as in the previous two problems that we have. Okay. So other questions? Okay, so let us proceed with the next problem here. Okay, so a taxi charges 450 initially and 310 per kilometer. Okay, how many kilometers did the customer travel if his total taxi fare was 2150? Okay, so again, a taxi charges 450 initially and 310 per kilometer. How many kilometers did the customer travel if his total fare was 2150? So let us solve this one. So we are looking for the number of kilometers traveled. Okay, so in here we let x be the distance traveled by the customer. Distance traveled by the customer. So we let x to be the distance traveled by the customer. And then just like how I did the previous problem, I'll put I'll use another variable to represent the total fare. Okay, and then so in that case, so we let t be the total fare, be the total fare. Then, so now we have the variables and the quantities. We use the given information. So the total fare, okay, then t, this is equal to 450. That's the flat rate. So I'll remove the dollar sign. I'll write 450. And then plus 310 per kilometer. But x is the distance traveled by the customer. So we have 3.10 x. Okay, so we have this working formula for this problem. And then we use the data. We use the data. Okay. So yeah, there is a question here. Is it okay if I write let x be the kilometers? Yeah, you can write that one. But yeah, so let me put that. I'll put here instead, let x be the distance traveled in kilometers. So in here, we have in kilometers. Okay, so I'll put that in parentheses to be more precise, that x is in kilometers. Okay. So anyway, let us continue. Now, the total fare was 2150. So the total fare was the total fare was 2150. So $21.50. So we now put that 2150 on the equation. Total fare was 2150. So we put that in the equation. And in here, I will put on the left-hand side this 450. So 450 plus 310 x. And on the other side, we have 2150. Okay? Okay. So there is a question here. Do we have to use t because we already have its value? What is, yeah, just like what I explained earlier. Just like what I explained earlier. This guy here gives you a formula. So if you have multiple questions, you have multiple questions. So what about the number of kilometers if the customer paid, say, 30.75 or 30.80, okay? Or what if the customer paid 29, okay? Or there's another question, how much fare is paid if the total traveled, the distance traveled is these kilometers, okay? So the importance of this is not emphasized in this particular problem because we are only asked for one particular distance, one particular scenario. But knowing a formula, okay, knowing a formula will help us solve more problem with the use of the same formula. Okay, so again, I will further discuss formulas in the second part of our discussion today when we start with section 3.2. Okay, so now we have this working equation. Okay, all we need to do is to solve for the value of x. So we have, so we put 450 from left-hand side to the right-hand side, so we subtract it. So what we get is 310x. This is equal to 2150 minus. So 2150 minus 450. But 2150 minus 450, this is 17, correct? This is equal to 17. So please check my arithmetic here. Okay? So 310x equals 17, and therefore we have what? The value of x. So x, this is equal to 17 divided by 3.10. Okay? 3.10. And what we will obtain, so here we just approximate it to 5.48. Yes, you can write 5.438, but yeah, you can write up to 2 decimal places in here. In fact, if we will be more precise with our answer, we can actually write 5.484. Okay, so we are up to meters. Okay, meaning 5,484 meters. So you can use that. But for this, I'll just write 5.48. Okay. So finally, we write the conclusion. Therefore, the total distance traveled. So therefore, the total distance traveled is approximately, take note of that, approximately, because we are not sure how close our value is. So approximately 5.48 kilometers. Okay, so 5.48 kilometers. Okay. Question for this problem? Okay, let us work on the last problem for this part. Okay, so a man had $185 in $5 and $10 bills. How many of each did he have if he had 7 fives more than tens? Okay, so a man had $185 in $5 and $10 bills. How many of each did he have if he had 7 fives more than tens? Okay, so we start with the presentation of the variables. So how many of each? So meaning we are trying to find the number of $5 bills and the number of $10 bills that the man had. So say let X be the number of fives. So number of $5 bills. 5. So let me write it in words. 5 bills. And then we write Y. we write y, or we let y be the number of $10 bills. $10 bills. Okay? And then according to the situation, okay, the man had $185 in total. Okay? Then, so X is the number of $5 bills. We have 5X. So $5 times the number of $5 bills plus we have Y is the number of $10 bills. So 10Y. This must be equal to 185. Okay? So we have this situation. 5X plus 10Y, this is equal to 185. Now, according to this, okay, he had 7 fives more than tens. Okay? Now, he had 7 fives more than tens. So the number of fives, okay, this is equal to the number of tens plus 7 more. Okay? So he had 7 fives more than tens. So the number of fives equals y, this is the number of tens, plus 7. Correct? So the number of fives is 7 more than the number of tens. He had 7 fives more than tens. So, from this equation and this equation, so we were able to write our x in terms of the y. Okay? We were able to write x in terms of y. So, we can replace this equation with another equation. So, we have 5 times x, but x is y plus 7. Okay, y plus 7. And then in here, 10y. So plus 10y. This is equal to 185. Hello? And therefore, we just have a linear equation in one variable. So we can just solve for y. Okay? So if we solve for y, we distribute this 5. We will have 5y plus 5 times 7 here. So plus 35. Then you have plus 10y. And this is equal to 185. And then we combine. So 5y and 10y, that's 15y. That's on the left-hand side of the equation. And then on the right-hand side, we put this 35 on the other side of the equation. So we will have 185 minus 35. But 185 minus 35, this is equal to 150. And then we continue. Y is equal to 150 divided by 15. And this is equal to 10. Okay? So we were able to find the value of tens. So we conclude the following. Therefore, The man had, the man had, so y equals 10. So the man had 10 $10 bills. So $10 bills, and 10 plus 7, that's y plus 7 here, and 10 plus 7, this is equal to what? 17 $5 bills. Okay? And you can check if he had 10 $10 bills, that's total of what? $100. And then if he had 17 $5 bills, 17 times 5, that's exactly 85. So 100 plus 85, that's your $185 in here. So you just do the checking part. Okay, but up to this point, we are good. So there's a question here. This is a very good question. If there are 7 5s more than 10s, shouldn't it be x plus 7 equals y? Look at your interpretation. So your x is $5, okay? Your y is your $10 bills. Your x is your $5 bills. If you do this, x plus 7 equals y. How many y's, how many y will you get? So if you interpret that, x plus 7, okay, you have the number of 5s plus 7. That will be the number of 10s. So which bills is more? The $5 or the $10? Okay? And then the situation tells us 7 5s more than 10s. You have more 5s than 10s. Yeah, you have more 5s than 10s. X represents the number of 5s. Y represents the number of 10s. You have the number of 10s and you have 7 more than the number of 10s. Correct? So in this equation, which is more, the 5s or the 7s? Or the 5s or the 10s? So in this situation here, the 5s are more than the 10s because this is just the number of 10s, and you add 7 to that number of 10s. That's the number of 5s. So you have more 5s than the 10s. Okay? Cool. Okay. Other questions and clarifications? You're welcome. So, that's the last word problem that we are going to solve for this part. So again, this is still in section 3.1, more word problems. So I want you to work on the other word problems that you will find on pages 41 and 42 of the 016 module. Okay? So now we will proceed with the next section of our course. Section 3.2, formulas. Okay? So basically, formula is any relationship involving two or more quantities or variables. So you have several variables and you relate them to each other. What you will get is a formula. Okay? Just like in our previous problems. we related the total amount charged with the number of rolls of papers. So that's a formula. We also related the total fare with the total distance. That's a formula. Okay? And there are more formulas. These formulas will actually help us solve problems in cases where you have a data for certain quantities or certain variables and you want to find the value of the other variables related by the formula. Okay? And not just one time. It's possibly that you have several datas, okay? And then you want to find those different values corresponding to the several datas that you have. Okay? So for our first formula in this set, here, let L be the length and W be the width of a rectangle. Okay? So for example, let us try to sketch. Let me sketch a rectangle and assume that it is a rectangle. So here is a rectangle. So assume this is a rectangle. Okay? So we usually let the length to be the longer side of the longer sides of the rectangle and W to be the shorter sides. So in here, this is your L and this is also your L. Okay? So the length of the rectangle and the shorter side, this is W and this is W. Okay? So now, the rectangle, let me just emphasize this. The rectangle is the set of points on this blue line here or these blue segments here. Okay? So this is the rectangle. Okay? Now, the area of the rectangle, it's the associated value, okay? It's the associated value given to the space inside those blue segments or the sides of the rectangle. Okay, so this shaded region here, this is the area of your rectangle. So the total amount associated or the number associated with this space enclosed by those segments or sides of the rectangle. That's your area. Okay, and that number, the area of the rectangle, which we represent by A, is given by the formula L times W. So we multiply length and the width. Okay? And now we look for the perimeter of the rectangle. So the perimeter, okay, it's the totality of these sides, okay, around this rectangle here. Okay, so if you are starting from this point, okay, and then you walk around along this side once, okay, and you return to that point again, okay, then the total distance you traveled, okay, is the perimeter of the rectangle. And notice the formula is simple. You walk around here, you traveled L, and then you traveled from this point to this point, you will get W. So you have your L plus W, and again on this side you have another L, and then from this point going to the original point you have another W. So the formula is just 2L plus 2W. That's the perimeter. Okay? Okay? So now, let us look at this. Example, the sides of a rectangle are 7 inches and 4 inches. find the perimeter and the area of the rectangle. So as I have mentioned earlier, okay, we usually let the length to be the longer side or the longer sides. So in here, we let your L be equal to, let me name this for precision. So length, okay, length L, this is equal to 7. And then the width W, this is equal to 4. Okay. Then we want to find the area. Then the area A, according to this formula, okay, according to this formula, it's just length times width. So you have 7. Okay, let me put the unit of measurement. Okay, so in here you have 7 inches, here you have 4 inches. So the area A, it's equal to 7 inches times 4 inches. And this is equal to, simple calculation, simple arithmetic, 7 times 4, you have 28, and you put inches squared. Okay, so the area of the rectangle is 28 square inches. Whereas for the perimeter P, so for the perimeter P, this is simply 2 times 7 inches plus 2 times 4 inches. This is equal to what? This is 14 plus 8. So 14 inches plus 8 inches. And this is equal to 22 inches. Okay? 22 inches. Okay? And maybe just a piece of observation here. So notice when we put the measurement, the unit of measurement, we have here 7 inches and then 4 inches. Notice that we simply multiplied 7 and 4, we got 28. And then it seems that the inches are also being multiplied to each other. That's why you have inches squared. Okay? Whereas in the perimeter, you have 2 times 7, that's 14, and there's only a single inches here. So you have 14 inches. Similarly, for this, you have 2 times 4, you have 8, and then inches. So you will get 22 inches. Okay? This one is called, if you are only going to consider the units of measurement in your formula, okay? Of course, the unit of measurement for the length, it's distance. Unit of measurement for W, it's also a distance. The area becomes distance squared. Okay? Distance squared. Okay? So that one is actually another topic in physics. We call it the dimension analysis. You will know if you have the correct measure, the correct unit of measurement when you do the dimension analysis. So you only consider the measurements, okay? You only consider the measurements and then multiply them or divide them as if you are multiplying dividing numbers, okay? You will get a unit of measurement for the other quantity that you got, that you have in the formula. So that's your dimension analysis. You are analyzing the dimension. Okay? So in here, it says that for area, it should be some distance squared. And for perimeter, it should be distance. Okay? Now, so there was a question, which L or which W should be used. Okay? Commonly, we use L or the length to be the longer side of the rectangle. And then W, the width, to be the shorter side of the rectangle. So in here, L, this is longer than, 7 is longer than 4, so we just put L equals 7. And W equals 4. Does that answer your question? Yes. So a lot of times, the longer, at least in this case, the longer side will be our length, the shorter side will be our width. Okay? You're welcome. So, this is one of the formula or two of the formulas that you might have seen before. Another set of formula here. So this time you have the following. Let R be the radius of the circle, of a circle. Okay? So in here, let me just write what a circle is. So assume this is a circle here. You know what a circle here? By definition, the circle is actually the set of points. The set of points equidistant from a fixed point. Okay? So in here, that's your fixed point. We call it the center. So fixed point, we call it the center. And all the points equidistant to this fixed point will be the circle. So it's just these points here. Okay? This is only your circle. Okay? So again, assuming that this is a circle. So that's only your circle. And just like before, when we talk about the area, it's the number associated to the space inside the set of points. So you will have this, okay? So you will have this space, okay? So there is a number associated to this space here, or this region here, and that is called an area, or the area, okay? Now, what is this radius? So the radius is the distance of any point on the circle going to the center. So this is the radius, R. So it's the distance from any point on the circle to the center. So for example, if this is the point I consider, going to the center, that must be equal to R. If I consider this point here, okay, then from that point going to the center, okay, that must be also equal to R, etc. Okay? So the area, so the number associated to the enclosed region here, so the area of the circle is given by the formula, pi times r squared. Whereas the circumference, it's your total amount traveled along the circle, okay, with one revolution. So for example, if you started at this particular point and then you walk around, okay, you follow the path of the circle, okay, just once until you reach your original point, okay, until you reach your original point. That's a circumference, okay? So sometimes you will hear it's one revolution, okay? So the formula for that circumference is 2 pi r. Okay? Now, I hope you are familiar with this Greek letter here, pi. So the pi, okay? So that Greek letter is actually a number for us. So that Greek letter pi, so pi, this is a number. This is a constant. Okay? And this is approximately equal to 3.1416. Let me just write up to 4 digits. Okay? Now, take note. I only say approximately equal. Okay? And I hope you remembered from the previous lessons that we had, we don't convert anything to decimal unless it's originally decimal, okay? And unless it's money. We do not convert anything to decimal. All numbers, fractions must be retained as fractions. Radicals will be retained as radicals if you cannot simplify them. This pi, okay, this pi should be retained as pi. You do not convert it. You do not press the symbol pi in your calculator. You just write it as pi. Okay? You just write it as pi. Okay? Any question or any comments on that? Okay, so let us look at the example here. Suppose the radius of a circle is 5 centimeters. Find the area in the perimeter of the circle. So in here, we are given r, the radius. Again, let me put the name. So radius r. So it's said to be 5 centimeters. Then we calculate for the area in the perimeter or the circumference. Okay, that's the perimeter. Then the area A, this is equal to pi times r squared, but r is equal to 5 cm. Okay, and then you square that. And what you will get here is 25 pi cm squared. Okay, 25 pi cm squared. So notice I did not convert this pi. I just write it as is. So you'll do the same thing. Okay? And again, notice centimeters squared. So it's like you are applying laws of exponent here. So a law of exponent. So you just distribute the square. So you distribute to 5, you distribute it to cm. That's why you have 5 squared, it's 25, and the cm squared, it's cm squared here. And notice, it's again distance squared. So that's for your area. Okay? And then for the perimeter, but in this case, we called it as circumference. So I'll write perimeter C. Okay, perimeter C. According to this, it's equal to 2 pi times 5 cm. So if you calculate this is equal to 10 pi cm. And again, it's consistent. It's consistent, so we only have the dimension cm, not cm squared, because it's perimeter. Okay, it's just the distance, not distance squared. Okay. Question. Okay. Next formula in here. So let A and B be the length of the legs of a right triangle, and let C be its hypotenuse. Okay? Okay? So in here, you have a right triangle. So a right triangle is a triangle where there is a right angle. So for example, in this guy here, we have a right angle in this part. Okay? And we call the sides adjacent to the right angle, so this side and this side here, we call them legs of the right triangle. And the side opposite to the right angle, so this is the right angle, this is the opposite side, okay, we call it the hypotenuse. Okay? So A and B be the length of the legs of the right triangle, so this is A and B, and C is the hypotenuse. Then the following formula holds. So A squared plus B squared equals C squared. So A squared plus B squared equals C squared. And this formula here, it's very famous. It's called the Pythagorean formula for the triangle. Okay? So it's called the Pythagorean formula. Okay. And then we consider another type of triangle here. Actually, the more general type of triangle. Okay? So in here, we consider the triangle. So you have triangle with sides or length of sides equal to A, B, and C. Okay? So in here, you see some segment here. Okay? Here, we labeled that H, and H is the height of the triangle corresponding to side B. Take note of that, corresponding to side B. Okay? So there's also another way of getting the height. It could be a different height. For example, we consider the height corresponding to side C. Okay? So this is possible height if we consider the side C. And there's another one, possibly from this point going to that point. That one is the height corresponding to side A. But what is common to all of these heights? When you consider getting the height or the altitude, okay, it's actually the segment joining one vertex of the triangle to the opposite side. You must have a right angle. Okay, you must have a right angle there. For example, if I consider this to be if this were height corresponding to base C, this must be a right angle. It doesn't look like right angle, but for illustration purposes. So if I want to consider the height corresponding to side C, okay, then this segment must be perpendicular, or this segment must form a right angle with side C. Okay, so that's the condition in getting the height of a triangle. Similarly, if you consider the height corresponding to side A, you will have that line segment. The line segment must form a right angle with the side A. Okay, So in this illustration here, the height corresponds to side B. Then we have the following formula. The area of the triangle is equal to 1/2 B times H. Okay, 1/2 B times H. Okay, the perimeter of the triangle is simply the sum of the sides. It's the same definition as in before, perimeter. You start from one point of the triangle, you walk around following the path of the triangle and stop where you started after roaming around. That's the perimeter. That's why you will have your A, and then you have B, and then your C, if you started from this point. Okay? So here, let us consider the problem. Suppose the sides of a triangle is given to be 4, 8, 10 units. 4 units, 8 units, 10 units. Find the perimeter of the triangle. So we are just looking for the perimeter. So in here, we can easily write perimeter P. Perimeter P, this is simply 4 plus 8 plus 10, and this is equal to 22. And let us put units because it's a more general unit. So units. Okay? Question. Question. Okay. Next formula here. Let C be the value of a given temperature in degrees Celsius. Then the corresponding degrees Fahrenheit, F, value of the temperature can be obtained using the formula F equals 9/5C plus 32. Okay? So, for example, if you are from the United States, you always use Fahrenheit there. You go to another country, okay, and they use degrees Celsius. So you can convert using this formula, or vice versa. If you are a non-US resident, okay, then you go to US, you convert, you are used to using degrees Celsius, you convert to Fahrenheit, use this formula. Okay? Now, let us consider these two examples. So convert 100 degrees Celsius, and we will label this as, so this circle here, small circle, as a superscript, and then C, so degrees Celsius. So 2 degrees Fahrenheit, so degree F. And then the second problem is we want to convert 98 degrees Fahrenheit to degrees Celsius. Okay? So to answer number 1, straightforward. Okay? We have your C equals 100 degrees Celsius. So C, this is 100 degrees Celsius. F, this is equal to 9/5 times C. So you have 100 plus 32. Okay? And then you do the arithmetic here. You will have what? So 100 divided by 5, that's 20. So 9 times 20 plus 32. and you will get 212. And then you just insert the label or the unit. So degrees Fahrenheit. So straightforward. Okay. For number 2, you are given the degree Fahrenheit. You are given F. This is equal to 98 degrees Fahrenheit. So for this, to convert this to Celsius, let's say we start on this formula. Okay. What we will have is you have 98 degrees, or let me remove that label first. You have 98 degrees and then 9 over 5 C, because we want to find that degree Celsius. We want to convert 98 degrees Fahrenheit to degrees Celsius. So 9 over 5 C plus 32. And then we just solve for C. Okay? So what we're going to do is to put 9 over 5 C on the left hand side of the equation. And then in here, the 32 will put it on the other side. Okay? So we will have 98 minus 32. And this is equal to 66. Correct? And then finally, we will get your C. This is equal to what? You have 66 in here. So 66, multiply it to the reciprocal of the coefficient. Okay? So multiply it to 5 over 9. Okay? Everyone follow? Everyone follows this? So we just compute this, do the arithmetic. We will obtain 110 over 3 degrees Celsius. Okay? So 110, you have 66 divided by 9. So you can simplify that to 22 over 3, correct? So let me put that mini step. So you will have 22 over 3 times 5. That's why you will get 110. So you will have 22, then 5 over 3. So if you simplify 66 over 9, so you will get 22 and then over 3 here. So you will get this guy. Okay, so notice, we just use this formula here. And then we input the value of F, we isolate C. Okay, but this formula we can actually use from here. You use this to calculate C. Okay, and then you will get another form of the same formula or equivalent formula. For example, if we try to rewrite this formula, what we will get is 9 over 5C. This is equal to F minus 32. And therefore, C, this is now equal to 5 over 9 F minus 32. So you will have this another form of the formula. So you could have used this to solve number 2 immediately. All we need to do is insert that 98 in here, and then you will solve for C. Okay? Yeah, so there is a question. From here going to here, what we actually did was to put this 32 on the other side. That's why you have minus 32. And then I interchange them. Okay, if you put this 32 on the other side, you will have 98 minus 32 equals 9 over 5c. And we use the symmetric property, we interchange them. So instead, we wrote 9 over 5c equals 98 minus 32. Is that good? So for example, let me write that again. So what we actually have was 98 minus 32 equals 9 over 5c. And then we just interchanged their location using symmetric property. Okay? So you have A equals B. So if A equals B, then B equals A. So you can just interchange their location relative to the equation. Okay? Okay. There's a question. You can also divide by 9, divide 66 by 9 over 5, correct? Yes, that's precisely what we did. Okay, so you have your 66 divided by 9 over 5. But again, we remember the definition of division. So we get the reciprocal of this guy here. Okay. And then there is this. Sir, for step 1, don't we do 100? No, we don't do that. Why do we have to do that? There is no anything there. So where is the 20 you are saying? This guy here, 9 over 5. Okay? 9 over, so this is the one you are talking about. We are multiplying 100 by 9 over 5. That's the formula in here. It's not 5 over 9. It's 9 over 5. Okay? So using the formula, we have the formula F equals 9 over 5C plus 32. So 9 over 5 times 100 plus 32. And then the 20, we obtained it by this, 100 divided by 5. That's 20. Are we good with that?
Sir,
Yeah.
do you mind explaining like the last step? 6
Which
over 5
step?
over 1? Like the on C, where C equals
This.
60. Like, I'm,
Yeah.
I'm confused why we flipped that and how we got 20.
Because from the left-hand side, it's like this guy here. So let us see. You have 9 over 5C equals 66. Okay? And then say, let us extend this. Let us extend this arrow here. Let us extend this arrow here. So you will have C equals 66 divided by 9 over 5, correct?
Yeah.
But again, just like this, definition of division, if you have something like A divided by B over C, this is equal to A times C over B.
Okay.
When you have the division, it's actually multiplication of reciprocals. So B over C, it's your fraction. But if you use multiplication, you have to get the reciprocal of B over C, which is C over B. So that's what happened here.
Perfect.
66 all over
Yes.
9 over 5.
That makes sense. So, and
Yep.
what about the 22? How do we get
22, where is the 22?
in the blue?
Here, because you have 66 over 9. 66, it's 22 times 3, correct? And then your 9, it's 3 times 3. So you cancel the 3.
Okay.
Is that good? So 66, it's 3 times 22. And then 9, it's 3 times 3. So you cancel the 3 from 66, you'll just have 22.
Oh, okay.
And then the 3 in the 9 will be cancelled, so you just have 3.
Perfect, sir. Thanks.
Yeah, you're welcome. Okay? So again, in here we started, so we want to convert 98 degrees Fahrenheit to degrees Celsius. So we are given F. That's 98 degrees Fahrenheit. So if we plug in using this formula, we just have 98 equals 9 over 5C. C is unknown. And then you have the plus 32 from there. And then we just put this 32 on the other side of the equation. You have 98 minus 32. And then we still retain 9 over 5 on this side of the equation. And then we use this property here. If A equals B, then B equals A. Meaning, you interchange the locations. You put B on the left-hand side, you put A on the right-hand side, and it's the same. So that's what we did in this part. So we put this on the left-hand side, we put this guy on the right-hand side. So you have 9 over 5C equals 98 minus 32. And 98 minus 32, that's 66. And then, to obtain C, we divide everything by 9 over 5. That's why we have here 66 all over 9 over 5. And again, definition of division, if you have A all over B over C, it's the same as A times C over B. So that's what happened here. So 66 divided by 9 over 5, it's the same as 66 times 5 over 9. And then you simplify, you will get 110 over 3 degrees Celsius. Okay?
I'm sorry, sir. How did we come up with 22 times 5 over 3?
So from here, 66. 66, it's, so 66. This is equal to 3 times 22. And then your 9, that's your 3 times 3. So 66 times 5 over 9, okay? You'll have 22 times 3, and then you have 5 divided by 3 times 3. So you will cancel the 3 here and the 3 here, and you will just get 22 times 5. 22 times 5, that's 110. And then on the denominator, we'll be left only with the 3. So that's our 110 over 3. So this is a good question. Sir, is there a simpler method of calculating step 2? Yes, derive this formula. Because this is simple. Starting from this formula, this solution here, it's very simple. If you are confused with this, then derive the formula, okay, relating C in terms of F, or writing C in terms of F. This is another formula, which is equivalent to this formula. Okay? And this formula, the way we calculated this, so notice, we put 32 on the other side. That's why we have F minus 32. In here, we put 32 on the other side. That's why we have 98 minus 32. Then you have your 9 over 5C. This is your 9 over 5C. And then we divide everything by 9 over 5. Or we multiplied F minus 32 by 5 over 9. That's what happened here. it's the same. This calculation here, okay, it's as simple as this formula here, okay? On the original formula, we wrote Fahrenheit in terms of Celsius. While on this formula, we wrote Celsius in terms of Fahrenheit. It's actually formula derivation. How do we write one formula or one variable in terms of the other? Okay? How do we write one variable in terms of the other? So is this now clear? Let us proceed with the next examples. So the volume V of a cone with base radius r and height h is given by this formula. So V equals 1/3 pi r squared h. Okay? So for example, you have a circle here, and then you have something like this. So here, r, it's the base radius. So the circular part here, that's the base, and its radius is equal to r. So it's the same definition since circular base. Whereas the height, h, it's from the tip of the cone going to the base. And again, similar description or criterion. This segment must form a right angle to the base. Okay? And then the volume. The volume, it's the amount. Okay? Amount, it's the fixed number enclosed by the cone. Okay? So the volume is calculated as 1/3 pi r squared h. So pi, so 1/3 times pi times r squared times h. Okay? So for the cone, this is a three-dimensional object. And you have seen a lot of cones. Ice cream, probably, ice cream cone, or your cone hat, or the orange cones on the roads of Montreal. Okay? So those are examples of cones. So here's the example. Find the volume of the cone if it has base radius equals 3 inches and height equals 6 inches. So in here, we have radius r. This is equal to 3 inches. And then height, h, this is equal to 6 inches. Therefore, volume, so volume V, this is equal to 1/3 pi, and then r squared, so 3 inches squared, and then h, 6 inches. Okay? So in here, you will get, so you have pi, or 1/3 pi, and then 3 squared, that's your 3 times 3. Okay? And then you have your 6. And then you have here inches squared. And then there's an inches again here. So you will get inches cubed. So if we simplify this, So this 3 here will cancel the 3 here. We will only get 18 pi inches or cubic inches or inches cube. So this is the volume of the cone. And again, volume, the dimension is distance cube. Okay? So for the perimeter, dimension it's distance. For the area, dimension is distance squared. And for the volume, we have distance cube. So we see here cubic inches. Okay? Question. Okay. So now let's have more examples here. So the remaining slides are just examples using formula that we have seen earlier. Okay. So here, find the dimensions of a rectangle whose perimeter is 64, and if the length, find the dimensions of a rectangle whose perimeter is 64 inches or 64 centimeters squared if the length is 2 centimeters longer than the width. Okay, so find the dimensions of a rectangle whose perimeter is 64 centimeters squared. Wait, why is there a square here? So there should be no square here. So forgive me about that. So perimeter, we only have distance, not distance squared. Okay. So anyway, to solve this, so we are asked to find the dimensions, meaning we are asked to find the length and the width. So we let L be the length, of the rectangle, and then we let W be the width of the rectangle. Okay? And we are given length is 2 centimeters longer than the width. So again, analyze how it should be written. So length is 2 centimeters longer than the width. So you have the width plus 2 centimeters. Correct? So length is 2 centimeters longer than the width. So you have the width, you add 2 centimeters, that's your length. Now, the perimeter is equal to 64. The perimeter P is given by the formula, so you have P, this is equal to 2L plus 2W, but your L, it's W plus 2. So we can replace the L with this condition here. So here we will have 2 times W plus 2 plus 2W. Okay? So we simplify that formula. 2 times W. Okay? So let me write in here. So you have 2W plus 4 and then plus 2W. correct? So our P, it's 4W plus 4. Okay? So this is the new formula. So again, we started with the formula that we know. P equals 2L plus 2W. But according to this, L is 2 centimeters longer than the width. Therefore, we can replace your L with this W plus 2. And now we have a formula for P with only one variable on the other side, W only. Now, now when P equals, when the perimeter equals 64, according to this, we have 64, okay? So we have 64 equals 4W plus 4. And therefore, we just solve for W. So we have 4W, and then we put this 4 on the other side of the equation, so it becomes minus. And then again, we flip them. We write 4W on the left-hand side. So this will be 64 minus 4, and this is equal to 60. And therefore, W, this is equal to 60 over 4, and this is equal to 15. Correct? So we have the value for W. But what's the question? Find the dimensions, meaning we need to find the length and the width. So the width is 15 centimeters, and the length is 15 plus 2, which is equal to 17 centimeters. Okay, and that's the conclusion. Okay. So there's a question here. Can we give the final answer as a decimal? As I have said, do not convert anything to decimal unless it's originally in decimal form. So do not convert anything to decimal unless it's originally in decimal form. You write pi as is. You write square root of 2 as is. Okay? You write 110 over 3 as is, and etc. So do not convert to decimal. Okay?
Sir,
Yes.
in the first formula, like the P equals 2L
Yep.
plus 2W. So my question is like, why did we assign a 2 to the W?
Sorry, why did we?
Like, why did we give a 2 to the W? Like,
Are you talking about this? No.
just on the bottom, sir, P equals 2L. Yeah, exactly. Like, why does the W have a like a 2?
Because that's a formula. You have twice the length plus twice the width. The perimeter. So you have a rectangle, right?
Yeah.
So LW, LW. You have two W's
Oh,
here.
okay. Oh, okay. Sorry.
Yeah.
Perfect, sir.
So
Thanks.
yeah, you're welcome. So 2L plus 2W.
Sir, I have a question.
Sure.
Yeah. So we need to memorize all these formulas, or they will be provided during the quiz.
Well, I can provide some of them. Like for example, volume of cone. It's not really common, but uh, formula for like area of a circle. Area was discussed during your high school probably. Area of circle, I mean. Area of rectangle.
Okay, so thank you. So
So
basically,
yeah,
you will provide the
those were not
objective.
common. I will
Okay.
provide the formula for those figures or formulas or whatsoever that are not commonly used. Yeah.
Okay, thank you, sir.
Oh, yeah, that's right. Some of us haven't been in high school for 15 years. I know. Um, that's why, well, at least, I don't know, at least you still know how to find the area of a rectangle. Or, I'm not, now I doubt myself if you actually know the area of a rectangle. But anyway, yeah, we'll see if I'm going to write them. But at the at most I can give the formula for, or at least I can give the formula for those figures or for those relationships which are not common. For example, conversion of Fahrenheit and Celsius. It's not really common to us. Okay, I don't even remember that. Okay, I just remembered it when I looked at it again. I am confused which one is 9/5, which is 5/9, until I saw the formula again. Okay, but for other formulas, um, I can give it, yeah. So it depends on the problem I'm gonna put. Okay, okay. Now let's proceed with the next problem here. Find the height of a triangle if its area is 54 feet squared and its base is triple its height. Okay, find the height of a triangle if its area is 54 feet squared and its base is triple its height. So in here, we want to find the height. So we let h be the height. Be the height of the triangle, okay, corresponding corresponding to the base of length b, of length b. So the length of the base, let's say it's b. Then, sorry, height, GHT. So GHT. So then, the formula, then the area. So area A equals 1/2 B times H. Now, according to this, the area equals 54 feet squared and the base is triple its height. Now, A equals 54 feet squared, 54 feet squared, and base B is triple its height, correct? So this is how we write it. 3 times h, it's triple its height. So the base is triple the height. So from here, so from these two informations here plus the formula here, we have, so let me remove the unit first. We have 54 equals 1/2 base times height. So 3h, that's your base, and then the h here. Okay? And if we simplify this, we will get 3/2 h squared. And then we just solve for h. We just solve for h. Okay? So if we solve for h, we start with, so h squared, this is equal to what? 2/3 times 54. So we put this on the other side. If we put that on the other side, we flip it. We get the reciprocal. That's why it's 2/3 now. Okay? And what's this? 2/3 times 54. That's equal to 36. Following? Okay? Now, we have here a nonlinear equation. Notice we have h squared and then equals 36. So for this particular example, I am preempting the discussion on solving linear equations. For this type of quadratic equations, okay, for this type of quadratic equation, we do the following. So if we have, say, h squared equals some number, okay, this is what we're going to do. So your h, this will be equal to plus and minus 36, or square root of 36. Okay? Or if you recall when we discussed radicals, so let me put it this way. You have 36 raised to 1/2. So recall that discussion of of radicals. They are the same. So this means that you have plus or minus square root of 36, and this is equal to plus and minus 6. Plus or minus 6. Now, I want to skip the discussion first in the plus and minus. Okay? What does this mean? It means that if you put positive 6, you square it, you will get 36. If you put negative 6 in this equation, you square it, you still get positive 36. This means that plus 6 and minus 6 are both solutions of this quadratic equation, h squared equals 36. You get two numbers, plus 6 and minus 6, as a solution of the quadratic equation. And I will explain further why we have two possible solutions. Actually, we have two solutions in this equation. So I will explain that further in our future lesson. But for now, accept it that h squared equals 36. Solutions are plus 6 and minus 6. Okay? So that's the solution of the equation. We go back to the problem. We want to find the height of a triangle. when we talk about height, it's actually distance. And when we talk about distance, we only take positive values. Okay? So since h represents height, so since h represents height, we only take, okay, so let me put it here. Since h represents height, which is a positive number, which must be a positive number, which must be a positive number, we only take we only take h equals 6 or positive 6. Okay, so that is the height is 6 feet. 6 feet. Okay, so that's the conclusion for the whole problem. Question. Other questions or questions related to this problem? So y is plus or minus? Again, I will explain that further in the discussion of quadratic equations. Other questions? So plus or minus, for now, just accept it. If you have h squared equals some number, then the h will be plus or minus square root of that number. That's why we have plus and minus in here. So for now, just accept that. But that will be explained further in the discussion of quadratic equations.
Sir,
Yes.
as what I get it last when you explained it, it's because positive times positive is equals the number, and negative times negative is equals the number, right?
Yeah, it's practically that, but there's more to that.
Okay.
Why we get plus or minus in this. But that's a property. If you multiply positive with positive, it's positive. If you multiply negative with negative, it's negative. But it's a different story when we have h squared equals something or x squared equals some number. Okay?
Okay, thank you.
Yeah, you're welcome. So, okay, so can you explain step 3 after a equals 54? So here, we just use this formula. So your a was 54 feet squared, so you have this 54 feet. 1/2, so that's your 1/2. B, but B is already 3h, so you have here 3h. And then the h, it's that h again. And then we just simplified this, so 1/2 3h h, that's just 3/2 h squared. Is that good? So we just use we just use the formula in here. Other questions? Okay, so let us go to the last example for today's lecture. Find the radius of the circle if its circumference is 32 inches. So we want to find the radius. So we just let R be the radius, of the circle. And then we also let C. We let C be the circumference. Let C be the circumference. Then C equals 2 pi r. So we are given the circumference C is equal to 32 inches. So when C is 32 inches, we have 32 inches equals 2 pi r, or simply divide everything by 2 pi, we'll get r equals 32 inches divided by 2 pi, or simply this is 16 over pi inches. So the radius is 16 over pi inches. Okay? Very, very straightforward. So question. So again, that's my last example. So for this section, work on the pages 46 and 47 of the 016 module.